Good day to all. Today we are going to see about the timers in that PLC, where we are using the timers and how it will use. We will see that program. See here the timer is used here. This is the open context switch. Before going that, in that PLC ladder diagram timer, there are three timers. First one is T on timer and T off timers, and another one is count retentive timers. T on timers, T off timers, and retentive timers. These are all the three timers used in that ladder diagram program in that PLC. What is that T on timer? See here, this 1.1 is the input over here. Then this input switch is connected with the timer. This is the output. This output is here. For example, this one is switch, we will say. This one is, will have a motor. For example, we'll take this one is a motor. This is the normal switch. If I on the switch, it won't run because here I am using that on delay timer. I'll put the time of this on delay timer is 5. So if I switch on this motor, the motor will run after 5 minutes. This is the example of on delay timer. In the name itself, you can understand that on delay timer. The process will have some time delay. We can use this in industry. Some particular places we need to start the motors or start the process after sometimes after we will press that switch. That will happen over here. This is the on delay timer. Then we will move to off delay timer. This process, see, if I press off this switch, for example, this is the motor. If I off the switch, the motor will suddenly won't off. It won't off suddenly because I am using this off delay timer. If I off the switch means, then this off delay timer will start running. After 5 minutes only, the motor will off. That is called off delay timer. On delay timer means the process will takes more time to start. More time means how much time you have given in that particular process, that will take. Likewise, in that off delay timer, the system will off which was we given for particular operations. If you are giving some particular minutes, then that will be have some operations. Then the retentive timer. See, retentive timer means whether it's off delay timer or on delay timer, the process will on. If we are on the switch, the process will on. For example, if I put 5 minutes, the timer will on. At the time of 3 minutes, maybe the current breakup or power supply cut. So this timer will have 3 minutes in the time. If the power will come again or I will rectify that problem, the timer will same in that particular timers. It will start from that 3.1 seconds. Whereas in that on delay timer or off delay timer, once the power is cut, it won't be in still the same minutes. Whereas the retentive timers, it won't return back to previous time. It will stuck in that particular time. Then that will start the same time. That is the retentive timers. Then we'll move up to counters. It is also one of the main process in that PLC, like timers. Here we will have two type of counters. First one is up counters. and second one is down counter. This counter is mainly used to count some process. See, if it is a sensor or we have a off on switch, if this button I will press over here for 4 times, because here I denoted a count of 4. Okay, if I turn on and off, on and off, on and off this switch for 4 times, then only this will blow. The thing is, we have to count for some certain process over here. That is called up counter. For example, in that manufacturing industry, the conveyor belt is running. It's running here. Some sensors over here. The sensor will have some bottle with full of some liquid like that. So after some bottles move, for example, if it is 4 bottles move, the conveyor should redirect because it is overflow. The conveyor should redirect from some other route. Likewise, we will have use here counters. If counter reaches that value, then that should be redirected. For this process, this purpose, the counter will use in that industry. Likewise, the down counters. Down counters you used for count how many, for example, if it is in parking area, how many cars are inside in that particular area, how many cars are out from that particular area. We can count from these counters. These are the counters in that programmable logic controllers. See, this is the normal ladder program, simple connections. This is switch 1 and switch 2. If the both switches is on, the output will blow. This end connection will have automatically in that particular program. Here it is the address of that particular switches. The SW1 switches have the address of 000, and this SW2 have address of 001, and this output coil have a address of 050. This input address and output address, timer address and counter address varies from software to software. For example, if it is a Logic Pro software, means the input may be like this: I semicolon 1/0, and output may be 0 semicolon 0/1. The timer is T4 and the counter is C5. Like that in one software. In some other software, the input address like for example, I equal to I dot 0 and output equal to 0.1, and the timer in that some software timer is denoted as T1 and the counter is denoted as C1. If we use more number of timers, we will count as a timer 1, timer 2, like that. T on count timer, on delay timer. In some software, it will denote a T0N, and T of counter is T off, like that. These addresses varies from the different softwares. According to that softwares, this address will occur. But the main thing is, if you are giving some address to that particular input, I'll give this in switch 1 for a input 0 point or 1.0 something like that. So this address should be same as in that particular system. In that site for input switch also having the same address what I am giving in that ladder program. Likewise, we have, for example, output or motor, I give the address 0.1 or O.1. So I have to give if it is a motor, I have to give the same address for this motor like 0.1 or O.1. Then it will be run. These are all about the ladder diagram program. Thank you.